Hello dear students, today is our 10th lecture of linear kinematics. In the previous class we have done numericals based on kinematical equation, uniformly accelerated motion, but U and A had opposite sign. Okay, in the previous class we have discussed U and A with the same sign, either positive or negative, but in the previous class we have discussed having U and A with the opposite sign. Okay, so if U and A and have opposite sign, then to get the scalar results like distance and distance in the nth second of motion, we should use the graphical method, and area under the graph will be giving you the displacement as well as the distance. Okay, one more question we do here. Suppose displacement of a particle moving along a straight line and velocity relation is V is equal to under root 9 minus 4s, and we have given U and A have opposite sign. I will be giving only hint for the questions. Okay, what we have to find: first part, velocity and speed at the end of 10 seconds. The second part is displacement and distance in 5 seconds, and the last part we have displacement and distance in the 4th second. Okay, so these results we have to get, and we have given U and A have opposite sign. Okay, so this expression is based on velocity and what? The displacement. And velocity and displacement, we have one kinematical equation, that is V square is equal to U square plus 2as. So if we come to the solution, V is equal to 9 minus 4s, it implies that V square is equal to 9 minus, we compare it with what? U square plus 2s. So comparing, what you get? U square is equal to 9 and 2a is equal to minus 4, or it implies that a is equal to minus 2 meter per second square. Here U is equal to plus minus 3 meter per second, but here we have to strictly take what? Plus 3 meter per second, because in the question we have given U and A have opposite sign. So since A has negative sign, then U must have what? The positive sign. So we have to take what? U here 3 meter per second. तो a and u हमने फाइंड कर लिया. ओके, नाउ व्हाट वी हैव टू डू for getting velocity and speed. For getting velocity directly we may use the formula. So we come to the first part. Velocity at any time t, the formula is u plus at. That is u we have what, 3, and a 3 minus 2t, and at the end of 10 second the velocity is 3 minus 2 into 10 minus 17 meter per second. Okay, then what about speed? It is always the magnitude of velocity if particle is moving along the straight line. The result is what? This one is the solution for the first part. Okay, B. Now we get displacement only. So displacement at any time t, we have what? ut plus half at square. So what is u? That is 3t, and plus half. A is minus 2 here. That is 3t minus t square. Now at what time we have to get displacement? It is at the end of 5 seconds. Okay, that is 3 into 5 minus 5 square, 15 minus 25, that is minus 10 meter. That is the displacement. Okay, then what is the displacement in the 4th second of motion? So displacement in the 4th second, say the formula is u plus a by 2 2n minus 1. Use the result. U we have 3 plus minus 2 by 2 2, n minus 1. In place of n we have to take 4 minus 1. Okay, so what we get? It is 2 4 8 8 minus 1, that is 7. It is 3 minus 7. It is the displacement in the 4th second of motion. But for getting the scalar results like distance and distance in nth second, we'll have to use the graph. So what is the velocity at the end of time t? 3 minus 2t. So we will have to draw the graph for this. Okay, for distance we have to draw the velocity time graph. Okay, what is the velocity at the end of time t? It is 3 minus 2t. We have velocity in meter per second, time is in second. 1 2 and 3, and minus 2t. At what time velocity becomes 0? Say 3 minus 2t naught time. 2t naught is equal to 3, or t naught is equal to 1.5 second. So see, at the end of 1.5 second, velocity of the particle becomes what? 0. So 1 second, 2 second, 3 second, 4 second, 5 second. Okay, it is 1 2. This time is 1.5. Okay, so 1.5. So draw the graph like this. Join these 2 points and draw the velocity time graph. Okay, now what we have to get? The distance covered by particle in 5 seconds. Okay, so 1 2 3 4 5 give the projection here. At the end of 5 second, velocity is 3 minus 2 into 5, that is what, minus 7. Okay, it is minus 7 meter per second. Now you get these areas. One area is this and the other one is this. So it is area A1 half. What about base? It is 0 to 1.5. And what is height? It is 3. 1.5 into 1.5, it is what, 225. 225 meter. Now you come to this area A2 half. What is base? It is from 1.5 to 5 second, that is 3.5. And what is this result? It is height is 7 here. So solving you get 12.25 meter. So distance covered by the particle in 5 seconds, t is equal to 5 second, is A1 plus A2, that is what, it is 2.25. okay, so 2.25 plus 12.25, the result we have 14.50 meter. It is the distance covered by the particle in the 5 second. Now you have to get the distance covered by the particle in the 4th second of motion distance. So what is 4th second? It is 1, 2, 3 and 4. The distance covered by the particle in 4th second means you will have to find this area. Okay, so at the end of 3 second, velocity we have 3 minus 2 into 3, that is what, it is minus 3. And at the end of 4 second, particle will have velocity 3 minus 2 into 4, that is minus 5. So we get this side, it is 3 and this side is what, 5. So it is the 4 second of motion, interval of 3 second and 4 second. So what we have, distance covered by the particle in the 4 second. So you get the area of this part. So say it is negative, so negative side will have negative sign. Area is what, half. Sum of parallel sides, so one is 3 and the other one is 5. So 3 plus 5. And what about height? It is from 3 to 4 second, so it is 1. So what we get, 8 by 2, that is 4 minus 4 meter. It is the answer. Okay, so this one was the third question based on the kinematical result when U and A have opposite sign. Okay, one question I am giving you for the homework. See what is question. Displacement of a particle moving along a straight line in the nth second of motion is Sn is equal to 2n minus 10. That is the displacement of particle in the nth second of motion. Sn is equal to 2n minus 10. Then what we have to find? First, velocity and speed at the end of 5 seconds. Second part, displacement and distance in 5 seconds. And third, displacement and distance in the 5th second. So this question is for homework. Okay. Now we come to the next part, that is motion under the gravity. Okay. So here G is acceleration due to gravity, that is 9.8 or nearly equal to 10 meter per second square. Okay. And this result is a constant result. This result may have positive sign or negative sign. Okay. Here G is constant. Now motion, in case of motion under gravity, if the motion is vertical, we come to the one dimensional vertical motion. Here one dimensional vertical motion. Okay. So see, in case of one dimensional vertical motion, in case of displacement, we have what? Height. Height is denoted by what? H. And the others have the usual signs like initial velocity U and final velocity V. Displacement, in place of displacement we have height in the nth second of motion. Okay. So height is H, and in place of A we have what? Acceleration due to gravity, that is plus or minus 10 meter per second square. So see, if A is constant and in place of A we have what? G is equal to constant, but G has positive or negative sign. So if A is constant, then say if A is constant, you use the formula what? V is equal to U plus AT. Now here you will have to use the formula V is equal to U plus minus A की जगह हमने क्या यूज किया? G. Now use displacement is equal to UT plus half AT square. So in place of displacement we have what here? Height. So height is equal to ut plus minus half gt square. Okay, now here we have v square is equal to u square plus, and in this case we have v square is equal to u square plus minus 2g h. Here we have displacement Sn is equal to u plus a by 2 2n minus 1. In place of displacement we'll have to use here the height, that is displacement in the nth second of motion, u plus minus g by 2 2n minus 1. Okay, so this one is the displacement in the nth second of motion. Sine of g, we come to the sine of g. See, what you take, motion under gravity g to be positive and against gravity z to be negative. But see, if you drop a particle in downward direction, if a particle is dropped, if a particle is thrown in the upward direction or any direction, then acceleration due to gravity is always in the downward direction. So see, never change the sign of acceleration due to gravity in the kinematical result. According to the sign of gravity, if sign of gravity is fixed, suppose you are considering g to be negative in the downward direction, then all the quantities in the downward direction will have the negative sign, and against the gravity the quantities will have what? The opposite sign. And if you are considering z to be positive in the downward direction, then all the quantities in the downward direction will have the positive sign, while the quantities against the gravity will have the opposite sign. Okay, that we have to consider. To see, sine of g must be fixed. It must be fixed. Must be fixed means either you take it positive or negative, positive or negative, because g always has the, here g is positive, here g is what? Negative. In this case you have considered downward coordinate to be positive, and here you have considered the downward coordinate to be negative. Okay, upper is negative and lower is positive. Here upper is positive and the lower one is what? Negative. So never change the sign of acceleration due to gravity in the question. Okay, now what we have, all the quantities obviously vector quantity in the direction of g will have the sign of g. All the quantities vector in the direction of g will have the same sign as g. If g downward is in the downward direction is positive, then all the quantities in the downward direction will have the positive sign. Like g is positive, so here displacement will be positive and also velocity will be what? Positive. And against g the quantities will have opposite sign. Like in upward direction the displacement is negative and velocity is also negative. And now if you are considering downward g to be negative, then all the quantities in the direction of g will have what? The negative sign, and against g will have what? The positive sign. It is the actual sign convention. Okay, and quantities opposite to the direction of g will have opposite sign. Okay, that is the sign convention. Okay, so never change the sign of g. G sign will be fixed, either you consider it to be positive or negative. In the direction of g, the quantities will have the sign of g, see, and against g the quantities will have the opposite sign. Okay, now we come to one more conceptual part, that is what should be the value of the initial velocity for a dropped particle. Say velocity of, it is actually initial velocity, I velocity of the dropped particle, initial velocity of the dropped particle. Say what we say, if I say if a particle is dropped in the downward direction, a particle has been dropped in the downward direction, see it has been dropped. So what you say, if we ask what is the initial velocity of the dropped particle, the maximum student says then that it is 0. So see, it depends on what? The velocity of the reference frame and the observer. If observer is outside the reference frame, either observer will be outside the reference frame or inside the reference frame. Reference frame is what? Where the experiment has been taken. So initial velocity of the dropped particle, say we take two conditions here. Initial velocity is denoted by what? U. It is the initial velocity. Okay, first part and second part. Say initial velocity of dot particle is 0 for an observer inside the reference frame. Like for me, this room is the reference frame, so I am inside the reference frame. If a particle is dropped inside the reference frame, for observer, I am the observer, initial velocity of the dropped particle is what? 0. So for an observer inside the reference frame, initial velocity is 0. See, for an observer inside the reference frame, initial velocity of the dropped particle is always 0. Okay, in this case you have to take u is equal to 0. But for an observer outside the reference frame, outside the reference frame, initial velocity u is equal to the velocity of a reference frame. It is what here VRF is the velocity of a reference frame, it is velocity of a reference frame. So it depends on the position of observer. If observer is inside the reference frame, then initial velocity will be always 0. But if observer is outside the reference frame, then initial velocity of the dropped particle will be equal to the velocity of the reference frame with both magnitude and direction. Okay. Now we visualize some conditions here. We take one example here, one experiment say. Visualize this condition, okay. So it is a trolley and this trolley is moving in the horizontal direction with what velocity? V0, okay. This one is an observer outside the reference frame, it is observer 2, and we take an observer inside the reference frame, it is observer 1, and a particle has been dropped over the trolley by the first observer, okay. So what are the conditions for the first observer and the second observer? See, this one is the reference frame for the first observer. To see, for the first observer, reference frame is what? It is trolley. While for the second observer, the reference frame is ground, static ground. Okay. So this particle P has been dropped to see, for observer 1, initial velocity of the dropped particle is what? 0. Suppose this one is x coordinate and this one is what? Y coordinate, okay. Then for the first observer, initial velocity of the dropped particle is 0, and what will be the motion of dropped particle for the first observer? Say the particle has been dropped, okay, from this point, u is 0. For the first observer, motion of the particle is what? A straight line in the downward direction, that is, path is straight. Path is straight for the first observer in the downward direction. Now if we come to the second observer, so for second observer, see, the particle has been dropped from the moving trolley. So this observer is watching this trolley, and what he is observing, that the trolley is moving and the particle has been dropped. This particle is moving what with the trolley. That means the velocity of the particle initial will be same as the velocity of the reference frame. So for the second observer, initial velocity of the particle u is equal to what? The velocity of the observer. So for the second observer, this particle is moving in what? The horizontal direction as the trolley, and see, simultaneously gravity is in the downward direction. Here also gravity is in the downward direction. So under the effect of gravity and the initial velocity, the particle motion is not straight. See, it is what? It is the trolley surface. So it is like this. For the second observer, particle is moving like this, and this path will be what? The parabolic path. So for second observer, path is curve. Okay, and here it is strictly parabolic path. Why it is parabolic, we'll discuss in the projectile motion in 2D. Okay. So see, for the first observer, path is straight, while for the second observer, path is parabolic. For the first observer, initial velocity is 0, while for the second observer, initial velocity of particle is same as the velocity of the reference frame. Okay, we come to one more example. See, suppose a trolley is moving in the upward direction with velocity v, okay, above the ground. One observer is over the ground and one observer is here. Observer 1. The first observer dropped a particle in the downward direction. Particle has been dropped from the moving trolley. Okay, so now we come to the conditions for observer 1 and observer 2. Nature of the path traced by particle. Now we come to the nature of path traced by the particles. Okay, particle for both the observers, observer 1 and observer 2. See, observer 1 is inside the reference frame moving in the upward direction. So for the first observer, initial velocity is 0. Okay, initial velocity is 0, but gravity is in the downward direction. And for the first observer, particle will be moving in the downward direction and the path is down straight. Okay, while for the second observer, see, second observer is on ground. So what is the motion of particle for the second observer? Say for the second observer, this trolley is moving in the upward direction. That means the particle with the trolley is also moving in the upward direction. The moment particle has been dropped, so for this observer, initial velocity is what? Same as the velocity of the trolley. Okay, so the second observer will be observing it moving in the upward direction initially, but gravity is against the motion of the particle. So after some time the particle will stop, okay, and then it will be again moving towards the ground. So motion of the particle is like this: firstly it is coming up, then it stops, then it come down. So upward and downward. So for these two observers, nature of paths are different. It is straight down, while it is firstly it is coming in the upward direction, then going in the downward direction. We come to one more example. Now we come to example 3. See, a fighter plane is moving in suppose it is a fighter plane. It is moving in this direction. Okay, it is moving with the speed v above the ground, and this angle is suppose theta. A shell has been dropped from the particle from the fighter plane. Okay, it has been dropped from the fighter plane. It is one observer. Okay, it is the pilot of the fighter plane, and the second observer is over the ground. It is second observer. Okay, now we come to the nature of path for these two observers. For observer 1, it is the reference frame for the pilot observer 1. Pilot is here, what? The first observer. So for the pilot, particle will be moving in the downward direction, and its initial velocity is what? 0, since it has been dropped, and gravity is in the downward direction. So for this pilot, this shell will be coming in what? The downward direction. Okay, he will watch this particle or shell to be moving directly in the downward direction. While for the second observer over the ground, for this observer, now particle has been dropped. So outside the reference frame, initial velocity of the particle is same as the velocity of the reference frame. So for the second observer, since the plane is moving in this direction, hence this particle is also moving in this direction, the initial velocity is equal to what? VO. Okay, this angle we have what? Theta. So for the second observer, particle will be moving like this. The path will be what? It will be a parabolic path. Here gravity is in the downward direction. Okay, so we have visualized 3 examples here. So these are 2 concepts. बच्चे गलती करते हैं. One is the sign of g, and the other one is what? The initial velocity of the dropped particle. Okay, now what formula should be used? for getting the results. Since acceleration due to gravity is constant, then all the kinematical equations are valid. Okay. See. First part. For getting time of flight, it is denoted by suppose t, and equation of motion we should use the formula suppose the upward coordinate is y coordinate, suppose the horizontal coordinate is x here and the vertical coordinate is y. The particle has motion in what coordinate? Y coordinate. So in place of displacement we use y is equal to uyt, it is the initial velocity along y coordinate, and plus half ayt square. So whenever you have to get time and equation for the uniformly accelerated motion due to gravity, then we should use the formula y is equal to uyt plus half ayt square, time of flight and equation. Okay. Next, for getting velocity at any height, that is suppose vy and the maximum height we should use the formula vy square is equal to uy square plus 2 acceleration along y coordinate into displacement along y coordinate. Using this formula you may get the velocity at any height h or the maximum height. Okay, maximum height is denoted by capital H. Okay. Next point, and for getting velocity at any time t, we should use the formula v is equal to u plus at vy uy and acceleration ay. Okay, so using these results we may find the velocity of particle at any time t. Okay, and acceleration in absence of any resistance in the vertical direction, a has value what? g. तो ये याद रखना है, in absence of resistance force F in the vertical direction, we have A is equal to plus minus C. See, A is equal to G in case of in absence of the resistance force in vertical direction. But if resistance force is defined in the vertical direction, then the value of acceleration will change in the vertical direction. Okay, that we have to remember. Now in the next class we'll be doing some more conceptual part on acceleration due to gravity and problems based on acceleration due to gravity with the force of resistance. Okay, thank you.